Okay, so we've already looked at the first type of switch, which is uncontrolled switch. So an example is a power diode. So let me make this too clear. There's a vast difference between a power diode and a signal diode. So a signal diode may have an operating current between maybe 0 to 1 amp. But when you take a power diode, it can range up to 1 kiloamp. So this is the greatest difference that you should know. So the signal diodes that we normally use in different circuits, like these linear electronic circuits, that's not what we are considering here. We are dealing with power diode. So when we get to the theory aspect of this power electronics, you are going to see all the theory behind all these type of switches. Now, the second type of switch is what we call the semi-control switch. What is a semi-control switch? Here we can control the turn on, but the turn off can never be controlled unless something is done to the circuit, as we did in the first video. So, example, the best example that we can have is an SCR, or silicon control rectifier. So let's quickly look at how the silicon control rectifier works. So if I have my SCR here, we can have a switch here, then we have our load over there. So this is my SCR. It looks very much like a diode, but that one has another terminal, a third terminal called a gate. So let's see how this thing works over there. Okay, this is a simple representation. If I apply voltage at this point, 0 to maybe 1 kilovolts, without doing anything to the gate, definitely this thing will turn on. So this is where we always say that it's undesirable. Why? Because if you increase the anode current to a threshold value, it is going to allow this one to conduct. But since it is not a controlled means of turning the switch on, we don't accept this method. At the end of the day, you may even damage the circuits, or you may even damage the switch. So this is an undesirable means of what? Or method of turning on the switch. So what we do is that we try to trigger it through the gate. So the another name for this triggering is just firing. So we try to fire, or we try to trigger the gate, so that it will allow this one to conduct for anode cathode current to flow. So we have our anode current this way. So we can have a situation whereby, though we are applying voltage, or we are applying current in the forward direction, this thing can still not conduct. Why? Because we have another junction that is being blocked inside. So when we look at the theory, you will see the architecture of this kind of SCR. Now, let's see, with us, for some time, you will see that this SCR will still be off, and this lamp will also still be off. But then when we give a pulse, or when we try to give a pulse of voltage at the gate, immediately we do that, we see that the SCR will turn on, then it will allow anode current to flow. Now, on the other hand, let's look at how to turn it off. Somebody will say that when I turn it on here and it starts conducting, then at the same time I can turn it off also by taking off the switch. This does not work that way. The SCR doesn't work that way. Immediately you have it working, then you have no control over the turn off. It's only the turn on that you have control over. So immediately you turn it on, or so far as you have turned it on and it is conducting in the circuit, there's no way you can turn it off. But then there are other external means. If you try to reduce the anode current below a particular value, which is called a holding current, immediately you reduce it below that value, then this thyristor will turn off. But then, since we are looking at how we can control it without using the circuit architecture, that is why the name is given by a semi-control switch, meaning we have control over the turn on, but there's no control over the turn off. So that is it about the semi-control switch, or an SCR or a thyristor. All right. So we talk about the fully control switch in the